All right. Welcome back, everyone. The morning session was terrific, and uh, people have mentioned Dave Pacheco a bunch. So I feel like the man who needs very little introduction, Dave Pacheco himself.
Thank you, Adam. All right. I have been using dtrace for kind of a while, in the last couple of years, especially, I've had the pleasure of introducing a bunch of people to dtrace, and so I thought I would share a couple of resources that at least I have found useful, and I will actually be interested to hear whether other people have found them useful as well. And I figured it might be good at some point, maybe later in this, to crowdsource other things people have found useful because I know people learn it in a lot of different ways. Anyway, one of the big challenges I know a lot of people have learning dtrace as well as other debugging tools and other tools, like test tools are also in this bucket, is that if you don't have a concrete problem in front of you, it's often hard to know where to start. But once you have a concrete problem in front of you, then you don't know anything about the tool yet. So you don't really know where to start with the tool either. And you're often under time pressure. And so one of my favorite things is Adam's dtrace bootcamp from several years ago. One of the things I like about it is that, where is it? Is that it opens saying that it's very much a work in progress. It is
Like, not much, been much progress.
this is from 2005, I believe. But what I really,
Not much work progress.
Past Adam has left us a note.
Yes. I'm trapped in a software factory.
The thing I really like about it is that it has both a bunch of examples, but then concrete exercises for you to extend those examples. And so you don't need a concrete problem to solve to go start playing with it. So as an example, I think it gives you an example of listing all the probes on the system. And then it's like, here's how you specify a particular probe. So now like enable that one probe. I should just actually go to the deck. Um, yeah. So, here's how you can list all these probes and then list some of them, combine these things, try using wildcards. The answers are not here, but I think each of the exercises is generally a pretty small extension of what it's already told you. So I think that's not generally a problem. And there's other good resources for learning about that as well. Anyway, there's a ton of stuff here. It goes through, it goes through all the basic stuff. It goes through listing probes, enabling probes, adding predicates, aggregations. I can't remember if there's associative arrays are in here as well. Thread local variables, stack, all the basic stuff. Like I think if you go through this, you will have at least seen all the stuff that people use on a daily basis with dtrace all the time, which is great. And it's in this sort of iterative way without having to have a problem in front of you. So I like that a lot. The thing that folks have told me is really useful for if you've really not seen dtrace at all before and you're like, I'm just getting started with it. The dynamic tracing guide, which is the ebook on the Illumos website, is both a great introduction to what dtrace is, including a bunch of examples of how to use it. And it's also a great reference. I think it is basically the canonical reference for so many things. So if you want to know what subroutines exist, actions, variables, let's see, I have that up over here. So this is on lumos.org books dtrace. The getting started section, walks through some examples similar to the bootcamp does, which is great. But then you get to all these reference sections for the different providers, like the profile provider. That's actually sort of a more complicated one to document because the probe names are dynamic. But like the proc provider lists all the different probes that exist in the proc provider and what they mean and what their arguments are and the types and things like that. So this is a really good reference and it's also a good introduction. It's also the only documentation, I think, for a lot of topics that I was going to call more obscure. I think you called arcane earlier around like anonymous tracing, postmortem tracing. I'm not sure I've ever used postmortem. I don't know. I have used postmortem. I've definitely used postmortem. I forgot. Oh my God. Been a little while. It's like a test. Never used anonymous tracing, but I have used postmortem tracing. Um, so if I were starting from scratch today, I would start with that book. Then I'd go through the boot camp to work through a bunch of those examples. And I think you'd have like enough to hang new content on that you could start playing around with it on real problems. Then there's the dtrace tips, tricks, and gotchas presentation, which is Brian's presentation from 2005. This one definitely assumes that you've already got the basics down already. But then it goes on to cover, what it calls tips, tricks, and gotchas. So tips are things that are documented but worth highlighting, I think is a good summary. Tricks are techniques that people learn on sort of like on the job as you play around with this thing that are perhaps not obvious. And Gotchas are things that problems that you run into a lot and how to deal with those problems. And I think a good example is there's a trick in here, which is using stop as a conditional breakpoint. So there's a stop action, which I love. So stop is an action. It's a destructive action you can put into any probe, which introduces basically a debugger stop into that process at that point. But there's a gotcha with it, which is that if you forget to put a predicate on your probe, it is very easy to accidentally stop every process in the system. Gotcha. And of course, so the deck talks about all those things, which is really good. Another one that people run into when you start building more complicated scripts are different types of drops. So you have buffer drops where you're collecting more data faster than it's being pulled out of the kernel, and so the data gets dropped, or dynamic variable drops where you run out of space for the dynamic variables. And it talks about how to tune those different things. And these are things that are like, it's not really like a bug. It's just like this is an intrinsic problem associated with what we're trying to do, but you still need to know how to deal with it and work around it. And so the trick goes through quite a lot of those things. I think of this as like, sorry, that's the wrong one. This deck is like, if the other stuff is like the book smarts of it, this is like building up a whole bunch of experience with dtrace. So if you've used dtrace for a long time, there's just all these patterns you learn. Like, what if I want stack traces only containing a particular function? It talks about how to do that. One way to do that is sorry, that's not what this slide is, but um, you can use an associative array, use a thread local variable to condition your later probe on having been in that function, and then grab a stack trace of that. Um, there's just a lot of stuff like that. The other thing it reminds me of is we've talked about this, like with Vim and MDB and other tools like this. I know all these people that use it every day that know that are like very fluid with it. And we all seem to know about 10% of what they're capable of. And that set only barely overlaps. And so every time you're looking over someone's shoulder, you end up seeing something you've never seen before. And you're like, wow, that's really cool. This presentation distills like a whole bunch of those things. So I think it's kind of like a way to fast forward through a lot of experience with dtrace. So I like that one. Then there's the dtrace book, which is like, if you're going to sit down and spend a lot of time on this and read something cover to cover, I think this is a great resource. This is Brendan Gregg's book. It goes through first principles. It goes through a bunch of examples. It's got tons of one-liners, and it's got a bunch of more complicated scripts. And it also covers implementation details and architecture of the things you're probably tracing, including kernel subsystems and applications and things like that, to explain how to trace them. Because very often, in order to trace something effectively to debug it, you need to understand something about how it works, and you need so that you can understand what points to instrument and what data you're looking for and things like that. So it has chapters on file system, on different levels of the networking stack, et cetera. So that's really useful as well. Another good resource, I think, are the scripts that are provided by a lot of projects. And this is very biased by the projects that I have been involved with or close to. So that first one is actually a set of scripts that I wrote while a joint for tracing Postgres. This is PG SQL Stat. So Postgres already had dtrace probes, and I wrote a bunch of these like stat tools, kind of like VMstat or whatever, for tracing the activity of Postgres. And I think these kinds of scripts, I think it's great when projects include USDT probes and then also ship scripts, like Alan showed earlier, that are using those probes and providing like a useful monitoring tool or whatever it is. And then you can learn from those, and you can figure out like how I want to apply that to something else. It definitely is like a more active learning sort of thing, because there's just, that's the documentation. Like, if you don't know anything about Postgres, this isn't necessarily going to mean anything to you right away. But I do think the patterns that you see in different project scripts are useful elsewhere and worth digging into if you want to better understand dtrace. So I've linked here in this deck, and I'll share it later. I've got links to all the things that I've been talking about: the decks, the dtrace book, the ebook, the official guide, and then all these projects. And I would love it if people in chat dropped other resources in general, but especially projects that ship their own descripts for their USDT probes. I think that would be really interesting to see. And I also discovered as part of this awesome dtrace.com. I don't know. Have you guys seen this before? No, I had not seen this.
Oh, awesome.
Awesome dtrace. And it just has like a ton of links to a
Wow.
whole bunch of different things, like Ruby and dtrace and
Yeah.
past dtrace.conf. I don't know who did this. And like, I've only been on this for, I know, right? I've only been on this for 5 minutes, and it could be these are all links to malware, but it seems pretty cool. It seems really nice. And that's all I got.
This is great. Awesome. So, um, thank you very much, Dave. And because you also, I think, help a lot of people learn dtrace at Oxide.
E-
What it, where do people stumble?
That's a good question. I don't know. I kind of feel like I want to ask some of those people. I haven't done it as much one-on-one at Oxide, um, to know like where people are running into that trouble. In fact, like, so I recommend the boot camp to like everybody, and I've been saying it for a long time. But I'm curious, like, how many people have actually like read it and gone through it and found it useful, or is it like I'm the only one that found that useful?
For what it's worth, some people are like, I read it and it was useful.
That's good. That's good
Like,
to know.
I don't get a lot more depth than that. I think they realize that I'm probably not, it's not actually the work in progress famous to it. But yeah,
Yeah, and reading the chat says the biggest place that I stumbled is what should I be tracing? And this is,
Yeah.
I mean, one thing we've said, I didn't said before that the knowing what question to ask can be really difficult. That's part of the reason why those UST probes are so important to give
Yeah.
you starting points to ask questions.
Yeah. Yeah, that's huge actually. And also the fact that dtrace has -L, like you learn that at the very beginning and then you forget about it for a while, but it's actually really useful when you walk up to a program you're debugging that you haven't seen before. So a couple of months ago, this is actually at OxCon, we were debugging a problem in our networking stack, not in the kernel networking stack, but in a userland daemon that was doing some of our data paths. And all I knew was that it had dtrace probes. And so I walked up to it with dtrace -L, and I saw that a bunch of them were called drop, and I enabled the drop ones, and I was able to confirm that it was not dropping the packets, and that was actually incredibly useful. So there's a couple of pieces around discovery that are there, but I think that is right from my general experience working with people with dtrace is that it's that very first like 10 minutes or half an hour of debugging a problem and trying to figure out like, wait, what do I do? There's 1,000 actions here. I'm not totally sure of the syntax yet. I don't know what probes to use. And that is tricky. And that is where you kind of need a real problem, I think, to motivate whatever you're trying to do. And I was thinking, like, how did I learn any of this? But I had the benefit of like being in a room with a bunch of people that use dtrace all the time. And I would just be like, I need help with this problem. And they'd be like, well, let's teach you how to use dtrace to solve this. So that's pretty fortunate. And I don't know how to replicate that more broadly, but it's a great way to go. You could, I don't know, like, is there like an open office, the dtrace office hours or something like that?
you should do that.
All right, I will do that. I'll do that.
So Matt in the chat is pointing out some of the stumbling blocks that he said was kind of interesting. One is around this versus self, so clause local variables versus thread local variables. I think we both I think the tips, tricks, and gotchas in there talks about it as the documentation, but that they can be counterintuitive, especially because both this and self have been used in different languages in different ways. So our apologies if that's totally counterintuitive how we've done it. Right.
I think part of the reason we did that was like we felt like they were both reserved-ish words. So like we we were going to conflict with things.
No, we're gonna conflict with them. We're just gonna override them
Syntax.
Tactically, only semantically.
Brains.
That's right.
I almost never use clause locals. I don't know. Is that a thing? I mean, an active thing, but like,
I've used clause locals a lot because they're also not clause local. I feel like this points to is like we call them clause local or probe local, but they're not. Right? They're like this probe has fired and it lives for the duration of that. I don't know that we've ever done a good job of explaining.
tips and gotchas. Let's go to that.
All right, sweet. Well, that's
Because the
Gotcha.
tip.
clause local variables are preserved. There are across process.
Yeah.
Mark.
Oh, I can see what it's going. It's trying to interact. Let's talk about something else. And then Matt does point out another place you stub his toe is with floating point arguments because that doesn't work.
I don't know. Why floating point? What?
Why was that PHO still?
What in use point?
Floating point? I don't.
It's
Like a
you know what? Never.
like an integer, like a string.
You're a witness, Keter. I'm done
Alright.
here.
All right. Cool. Thank you, Dave.